Black holes are one of the strangest objects in the universe. They don't make much sense at all. How do they form? And what happens if you fall into one? Stars are enormous collections of hydrogen atoms that collapse from gas clouds because of their huge gravity. In their center, nuclear fission turns hydrogen atoms into helium, releasing a lot of energy. This energy pushes against gravity, keeping a harmonious balance between the two forces. As long as there's a fusion in the center, a star remains very stable. But for stars with enormous masses, the pressure at the core allows them to originate heavier elements, until they reach iron. Unlike helium and hydrogen, the reaction that creates iron doesn't make energy at all. Iron builds up at the center of the star until it reaches an unstable amount, and the balance between radiation and gravity is suddenly broken. The core collapses on itself. Within a fraction of a millisecond, the star implodes.
Moving at about 25% of the speed of light, feeding more mass into the center. It's at this very moment that all the area's substances in the universe are originated. The star collapses in a supernova explosion. This creates either a neutron star, or if the star is gigantic enough, the entire mass of the core creates a black hole. If you took a look at the black hole, what you really see is the event horizon. Anything that gets past the event horizon needs to be traveling at a faster speed than the light itself. Basically, it's impossible. So we just see a black ball, reflecting nothing. But if the event horizon is the so-called black part, what is the whole part of the black hole?
Singularity. We have no idea what it is. A singularity may be infinitely dense, meaning all its mass is concentrated into just one point, with no length or height, or something completely unrelated. Right now we just don't know. It's like dividing by zero, for example. By the way, black holes do not suck things up like a vacuum cleaner. If we were to trade the sun for a massive black hole, nothing much would change for us, except that we would freeze to death, of course. Black holes come in different sizes. There are stellar mass black holes, with a few times the mass of the sun, and the diameter of a city, for example, and then there are supermassive black holes, which are found at the heart of every galaxy, and have been expanding for billions of years. As powerful as black holes are, even they will eventually disappear through a process called Hawking radiation. To understand how this works, we have to look at empty space. Empty space is not actually empty, but filled with virtual particles popping into existence and annihilating each other again.
Right on the surface of a black hole, one of the virtual particles will be drawn into the black hole, and the other will escape and become a real particle. So the black hole is essentially losing energy. This happens incredibly slowly at the first and gets faster as the black hole loses mass. When it arrives at the mass of a large asteroid, it's radiating at room temperature. When it has the mass of a mountain, it radiates with about the heat of our sun, and in the last seconds of its life, the black hole radiates away with the energy of billions of nuclear bombs in a huge explosion. This process is incredibly slow. The biggest black holes we know might take up 1 billion of years to evaporate. This is so long that when the black hole's hole radiates away, nothing else will be around to witness it. The universe will become empty long before then.